Hey guys, so welcome back to my channel. What I'd like to show you today is a little update and new builds with some nice new components of my Asterix frame. So this is the version 1.1. I released the frame a few months ago, I think in February. And it's basically the bigger brother of my Calimero 3D printable toothpick frame. If you compare both, they have this I'd say signature design with the double arms. So this is I'd call this a classic 3-inch frame. So this is not a super light 3-inch toothpick style here like the Sanchez, which is also a 3-inch frame, but very different. And also this one is not 3D printed. So this is a classic 3-inch frame for 20 by 20 stacks and 14 to 15 millimeter wide motor status. So typically these kind of builds you would put some 1407 or even 1408 motors or 1506, 1507 motors. So yeah, a classic good old 3-inch frame. Yeah, the motor mounts are 12 millimeter M2, which is also pretty standard in this class. I have printed this frame here out of Saint Smart PETG, which is a slightly softer material, but still this thing is very, very stiff. So I don't think I will have any stability issues here for a 3D printed frame. This thing is really, really tough. In terms of weight, I can quickly throw this on a scale. So 59 grams, a little bit under 16 grams. So this isn't too bad. I mean, obviously there are lighter 3-inch frames, but to have a 3D printed frame that holds up to some real use, I needed to make it a little bit heavier. So the design updates I did compared to the version 1.0, this is the 1.0. I made the arms a little bit thicker, more stable. If you compare those, it's a slight update. But the biggest change is on the motor mounts. So basically it all started when I got these really shiny and beautiful 1506 RC and power motors. These are 4300 kV, and they just didn't fit the old design. So as you can see, there are these kind of little cups here for the motors that go all around, and these don't fit 50 millimeter stator sizes. So I updated this. What this new design now has is arms that basically go all around the motor, right? This, like here, which should be really good for stability. So these mounts are pretty thick here, and the arm comes all around. So this will be very, very stiff and strong, I hope. And yeah, the only downside, of course, is you will need naked bottom motors, like this one, so that the bell can kind of look over the frame. So not all motors will fit, but in the Thingiverse post I will list a list of suggested motors that fit this frame. Other things I didn't change, so I still have this nice little top plate here where I designed a way to easily mount the VTX antenna. So this goes through here. You can put the VTX below the top plate and put a little zip tie here through these holes, and you're good to go. I still have the what I call slot mounts. So instead of just having holes to mount your stack, these are slots. The nice thing is that depending on what components you use, you will want to place them a little bit differently. So this gives you just some room to work with. You can kind of move around the components in this range, and it will help you build the frame. So yeah, that's it. That's the version 1.1 of the Asterix frame. And now I will show you what kind of components I picked for this little build that I will do for myself. Alright, so let's start with the powertrain I'm going to use. These are the RCN 1506 motors I'm going to use, and these are basically what motivated me to do another 3-inch build, to be honest, because they just look really nice. They have this amazing blue, pink, anodized aluminum, and I hope the video does this justice, but they just look stunning. They seem to have an extremely good build quality. The air gap on these motors is ridiculously tight. Everything is obviously executed super well, so this seems to be very, very good quality. They are 4300 kV, which is quite a lot for a 4S 3-inch build. So usually motors for such a build would be in the 3700 to 4000 kV range. This is 4300, so they might be really amp hungry, but probably also really fast. So I'm looking forward to try this out. Because they might be amp hungry, I decided to use 850 milliamp 4SR lines. I hope these will supply all the amps that these motors can pull. In terms of other electronics for the drivetrain, so what I'm going to use is the Diatone F405 Mini. So I have the 30x30 version of this stack, and it has been pretty reliable. Never had any issues with it. They usually also have pretty good board layouts that are easy to work with, easy to solder on. So as you can see, all these pins here are nicely arranged here. This should be quite nice to work with and a really good layout. And as I mentioned, I think they are, for the pretty cheap price, they also have really reliable. This is why I'm going to use this F405 Mini from Diatone. In terms of camera, so what I have here is the Runcam Phoenix Oscar edition. So I saw some YouTube videos on the footage and it looked really good. So I like these new big sensor CMOS cameras, and I hope I will like the picture on this one too. What this has and what should be really cool is that you can access the camera menu through Betaflight. So if you're goggles and with the radio, by wiring an RX and TX pin to this camera. I will probably have to use the pins for the LED strip because it needs to be specific ones, but there are videos explaining in detail how to do it, from Joshua Bartwell, for example. The VTX I'm going to pair this camera with is this one from HGLRC. I quite frankly think that this is pretty much a copy of the TBS Unify Nano or Nano 32, but also it's just a third of the price. It's just as small and light. The performance in terms of output power isn't quite as high as the TBS Nano 32 that has 400 milliwatt. This only does 50 milliwatts, but 50 should be, for a small 3-inch build, more than I need. So I'm gonna use this little cheap and very light VTX. Comes with a linear antenna, so I'm also covered on that. And yep, other small stuff. I mean, I'm gonna use an XT60 because my batteries, the Tattoo 850 outlines, already have an XT60 connector, so I'm not gonna change this to an XT30, and also this should be a pretty amp hungry build. So the XT60 isn't gonna hurt. Alright, so these are the components. Here's the frame, and I think now I'm pretty much ready to go for the build. So I'm gonna skip ahead, not show you the entire build video. I think there are enough of these up here on YouTube, and then we will discuss the results. Alright, so here we go. This is the finished build. It was quite easy to build, didn't take too long. No problems at all on the way, to be honest. Everything worked as I expected. Just one thing, I had to flip the stack 90 degrees because the wires on the motors were a tiny bit too short to fit it as I initially wanted to have it. So I wanted to have the USB sticking out on the side. Now I just flipped it 90 degrees so the USB is still accessible here in the back, and this way I didn't have to extend any motor wires. I had to move the stack back quite a bit, so it's, if you look at these slots to mount the stack, it's pretty much here on the end, because the camera is quite big, so I had to make a little bit of room, but it's not a problem at all. This is still, if I mount a battery on here, this is still no problem at all, although it's not completely in the middle. The battery still sits quite nicely underneath it, so no problems here. What I didn't finally hook up with the board was the camera control. So I watched Joshua Bart's video, and honestly it was just too complicated. If you don't have dedicated pads for camera control on the board, and this diatone doesn't have that, you can use another UART, and you have to build in a resistor, and that was just too complicated. Honestly, I'm just gonna use the camera on stock settings. I expect that the stock settings will be good enough for me. Should be fine. Apart from that, everything works well. I didn't have a chance to fly this yet because the weather is quite bad outside, but I'm gonna do this next weekend. I'm gonna race again, so I will maybe rip this around the track or fly it somewhere close by. And yeah, so I'm looking forward to do that. Before I finish this video, let's take a quick look at the weight of my build. So with the battery, it's unfortunately slightly, or quite a bit actually, over the 250 grams all-up weight you have to meet to be free of most of the regulations in the European Union. So this is almost 40 grams too heavy, but honestly I wasn't expecting anything else with these quite big motors, the big battery. This is not an ultra light build, and this is fine for me. I will just have to stick a little plate here with my name and address, and that's all I have to do. So without the battery, weight's pretty exactly 178 grams, which isn't bad. This is roughly the range that I expected. So yeah, that's it. That's my latest build. Thanks for watching. As always, I will upload all of these files for you to use for free on Thingiverse. All the parts I use are linked below in the video description and on the Thingiverse post. So yeah, thanks for watching guys, and stay tuned.